Sound. Sound is a form of energy that propagates through matter as a wave. The scientific study of sound is called acoustics. Humans perceive sound by the sense of hearing. In humans, hearing takes place whenever vibrations of frequencies from 15 Hz to about 20,000 Hz reach the inner ear. The Hertz Hz is a unit of frequency equaling one vibration or cycle per second. Such vibrations reach the inner ear when they are transmitted through air. Though sound mainly means the vibration that travel through air and can be heard by humans, scientists and engineers use a wider definition of sound that includes low and high frequency vibrations in air that cannot be heard, and vibrations that travel through all forms of matter, gases, liquids, and solids. The matter that supports the sound is called the medium. Sound propagates as waves of alternating pressure, causing local regions of compression and rarefaction. Particles in the medium are displaced by the wave and oscillate. As a wave, sound is characterized by the properties of waves including frequency, wavelength, period, amplitude, and velocity or speed. When you strike a tuning fork with a rubber hammer, it vibrates with certain frequency. The frequency does not change even if you hit it harder. Similarly, the frequency of a simple pendulum does not change even if you increase its amplitude slightly. A load suspended from a spring when pulled and released also starts vibrating with certain frequency. The frequency of the tuning fork depends on the dimensions. The frequency of simple pendulum depends only on its length. As long as the length of the pendulum does not change, it oscillates with the same frequency. Similarly, the spring mass system vibrates with the same frequency as long as the spring and the mass suspended remain the same. Thus, every body has its own frequency called natural frequency, and the oscillations are called free or natural oscillations. Once the body is excited, it vibrates on its own. Thus, when a body is set into vibration, then left to itself, the vibrations are called natural or free vibrations. It is of a common experience that the amplitude of a vibrating body continuously decreases with time. Why? The air around it offers resistance to vibrations. Periodic vibrations of decreasing amplitude are called damped vibrations. If we strike a tuning fork and then press its stem against the top of a table, the sound becomes louder because the table is forced to vibrate with the frequency of the tuning fork. Since the tabletop has a much larger vibrating area than the tuning fork, these vibrations produce a louder or more intense sound. The vibration of the tabletop, which take place under the influence of external periodic force, are called forced vibrations. When an external periodic force is applied, a body does not vibrate with its natural frequency, but gradually acquires the frequency of applied periodic force. When a body executes vibration under the action of an external periodic force, and the vibrations of the body are called forced vibrations. The term sound is sometimes restricted to airborne vibrational waves. Modern physicists, however, usually extended the term to include similar vibrations in other gases, liquids, or solid media. Physicists also include vibrations of any frequency in any media, not just those that would be audible to humans. Sounds of frequencies above the range of normal human hearing, higher than about 20,000 Hz, are called ultrasonic. In general, waves can be propagated or transmitted transversely or longitudinally. In both cases, only the energy of wave motion is propagated through the medium. No portion of the medium itself actually moves very far. In transverse waves, the material through which the wave is transmitted vibrates perpendicular to the wave's forward movement. As a simple example, a rope may be tied securely to a post at one end, and the other end pulled almost taut, and then shaken once. A wave will travel down the rope to the post, and at the point it will be reflected and return to the hand. No part of the rope actually moves longitudinally toward the post, but each successive portion of the rope moves transversely. This type of wave motion is called transverse wave. Similarly, if a rock is thrown into a pool of water, a series of transverse waves moves out from the point of impact. A cork floating near the point of impact will bob up and down, that is, and move transversely with respect to the direction of wave motion. A sound wave, on the other hand, is a longitudinal wave. As the energy of wave motion is propagated outward from the center of disturbance, the individual air molecules that carry the sound move back and forth, parallel to the direction of wave motion. Thus, A sound wave is a series of alternate increase and decrease of air pressure. Each individual molecule passes the energy on to the neighboring molecules, but after the sound wave has passed, each molecule remains in about the same location. There is a special phenomenon called resonance associated with sound. Resonance. It is a phenomenon in which one of the two bodies of the same natural frequency is set into vibration. The other body also vibrates with large amplitude under the influence of the first body. Resonance is an important phenomenon in nature. The following are some examples of the phenomenon of resonance. When soldiers cross a suspension bridge, they are asked to break their steps. This is because if frequency of vibration of their marching becomes equal to the natural frequency of the bridge would vibrate with large amplitude due to resonance, and the bridge could collapse. A pronounced rattling sound may occur in a car when it is traveling at a particular speed, but if it travels faster or slower than the speed, no rattle occurs. This is due to resonance between the car engine and the body of the car. When we tune a transistor radio, we are actually adjusting its natural frequency to that of incoming carrier electromagnetic waves from a radio transmitter. When the two frequencies match, maximum energy is absorbed from the incoming wave and the sound is clearly heard with appreciable amplitude. Consider a swing on which a child sits. When the swing is given a series of pushes by the mother of child, with a frequency equal to the natural frequency of the swing oscillates with a large amplitude. In this case, resonance occurs between the oscillatory force applied by the mother and the swing. Noise and sound often mean the same thing. When they differ, a noise is an unwanted sound. The auditory experience of sound that lacks musical quality or sound that is disagreeable auditory experience may be called noise.